Okay, Geometry Chapter 10 review. Our Chapter 10 test is Friday. It's going to be the 11th, 2 days from now, 5/11. If you have any late work or corrections that you want to turn in, those are due on Friday. And also your notes packets and your review, this entire review will be due on Friday. Somebody look and see how many problems there are beyond 28. How many? So you guys got 20 more. Let's try to get through those today. I'll review 1 through 48. These guys are all due to me on Friday if I don't have them already. And we still have 10-7 to talk about today. We'll do that before we get further into our review. First things first, tell whether the line segment array is a radius, chord, diameter, secant, P to K. Best name for that one's going to be a radius. 2, N to M. Name for that one's going to be a chord. 3, it's listed as a ray, JL. Ray, JL, that's going to be a tangent. It hits the circle at exactly 1 point. Number 4, segment KN. Where is KN? It's a chord through the center. That's going to make that a diameter. Line NL is going to be a secant. It's a line that goes through secant. A line that goes through a circle and hits it twice. Segment PN is another radius. Moving on. Common tangent is internal or external. If I remember right, the internal is if you connect the centers, the tangent goes through it. So I think number 7 is internal. Check your notes on that one, you guys, but I'm almost certain 7 is internal and 8 is external. External. My memory serves that if you can connect the 2 points and it hits that tangent line, that it's internal. 9 and 10 we had worked through in class. I'm going to put a brief up here on this one. This was theorem 10.1. Theorem 10.1 and 10.2 weren't in our notes packets, so we had to write them in. 9a squared minus 30 equals 3a. And again, in my class, we've done these. We're going to solve this we're going to use our calculators as a tool to look at this quadratic equation to get a solution to it. We set it equal to 0. We go put it into our y equals the whole equation. When we looked at the parabola for this one, it was going through the x-axis. That parabola was going through the x-axis just before -1 or -2, and then it went right through at 2. So the solution to this, when we put this all in our calculator, is 9x squared minus 3x minus 30. We found that when y was 0, we had approximately -1.95, approaching -2, and x was positive 2, and positive 2 is the only answer that makes a difference for a geometry problem. Number 10, similar in the setup that you have to set these two things equal to each other. It looks ugly out of the gate, but one nice thing about number 10 is when you set these equal to each other, you can really start undoing things, and lots goes away. We don't have to use we don't have to use graphing to solve this. We can get rid of these c's and solve for c. First thing I'm doing is taking away that 9c from both sides, just because it's on both sides. Might as well get it out of there. That gives me 2c squared plus 6 equals 14. I can keep on doing. I can my 6. 2c squared equals 8. I can keep on doing. I can divide by 2. c squared equals 4. I can keep on doing. The square root of c squared, the square root of 4. C is either 2 or -2. -2 times -2 is also 4. We're going to use this answer because it's a geometry problem. Number 11, and again, I know this is quick, but we had done that one in class. Number 11, this is going to take a little bit of time here too. Find the value of the variable. This is a point of tangency. So what we're dealing with here is a small right triangle. Draw it on your paper. Where this side is 9, the radius, that was like, here's the z to w piece. Here's x out here. This side needs to be expressed as 3 plus r. Bringing that off the circle from the drawing, and to find the value of r, then we apply the Pythagorean theorem. 9 squared plus r squared equals 3 plus r, that whole quantity squared. Now when I go to simplify this, 9 squared is 81. I can just write r squared back in here. And I'm going to go use my idea, the area model, the idea behind like the Punnett squares in biology. Multiplying through, we've got 9, 3 r's, another 3 r's, and an r squared. When I get that going on, I can pull that out. 9 plus 6r plus r squared. Take a second here. I can see a lot of people stopping off on this one. This was section 10.1, and I know in our notes there's quite a few examples of this, and also on the back of our Maintaining Math Proficiency, we messed around with this type of thing as well. May even have come up on your 10.1 to 10.3 quiz. I'm going to start undoing. Take r squared away. That's nice. 81 equals 9 plus 6r. Take 9 away. 72 equals 6r. Divide by 6. I think it's 12. 72 divided by 6. I think it's 12. Now, number 12 is putting us in a situation where we have to decide if AB is tangent. So the question is this: is there a right angle at B? And the way that we test that is to see if the legs, so is this a right angle is the question. If the potential hypotenuse is 52, taking it right off the drawing, one leg is 48. And I don't know if you guys noticed this, but 10, I believe, is meaning to represent just the radius. So this side, I'm going to mark this side as 20, not 10. If you tried it with 10, I want you to take a look back at it again. This is 10. It looks like it's marked just as the radius. So that whole diameter, that whole other leg of the right triangle, I believe, is 20. I'm talking about right here. 20. 20. And then again, to prove if this is a point of tangency, does this make a right angle? Because if it does, then B is a point of tangency. So is 20 squared plus 48 squared, is it equal to 52 squared? Did I just, okay, 20 squared. This is 400. Somebody give me the 48 squared or the 52 squared. $2,304 and 52 squared, what's that? 2,704. Oh yeah, that looks like it's going to be equal, doesn't it? So 2704 is equal to 2704. So point B is a point of tangency as it's a right angle. That's how we test that. Triangle is right at point B. So that wraps up 10.1. 10.2. Taking just 3 more seconds here while people are switching papers. Now for problem 10.2, or section 10.2, I think I'm going to do some of these right on this drawing. It makes a little bit more sense. When I look at what I'm going to have to use, there's all my examples here, and then use the diagram above. As soon as I look over here, there's some things that I want to do. I know that L to N is a diameter, so I'm just going to put 80 degrees in there. I think it's going to help me. 180 lie on a line. That's how I knew that. And if I think about this other semicircle here, 120, I'm going to put a 60 right here. And so that could help me get these arc measures. K to L. What's K to L? If you don't have it color-coded, you should. These are all central angles, you guys. Central angles and their arcs are the same. If you don't have these color-coded, do it. What's L to M? That's 60. I already had that one in there. Oh, that doesn't look very different. I got orange and yellow. It doesn't look very different, but it is. K to M, I'm going to go the shortest way to K to M because it's listed with 2 letters and it's a minor arc. So K to M is going to be 100 plus 60 or 160. And then why don't I drop some green on there? That'll stand out. And then K to N. Oh yeah, see my theory of putting all those central angles in there, got every single answer on the page for me. These are central angles. Central angles and their arcs are their intercepted arcs are the same measure. 13, 14, 15, and then with the red arcs in 16, 17, we talked about that in every class. And I like how we wrote this here in 4th hour. 17 and 18. We talked about these in every class. In 17, these arcs have the same measure in terms of the central angle that it opens to them because they're vertical angles, but that doesn't make them congruent. They need to also have the same length. They both open to the same central angle, but they're circles. They are on circles that have different radius measures. So you need to say something about how 17 is not congruent, even though their arc measure is the same, their arc length is different because they're on different circles. Whereas in 18, these guys both have a central angle of 95 degrees, so that makes their arc measure the same. And then they both are on a circle that has a radius 6, so that makes their arc length the same as well. So we can say that in 18, they're congruent. Both things have to be true. Same central angle opening up to the right, the same arc, and then radius has to be the same. All right, so using chords, where are we at here? I think I'm going to stop this one.